Okay, we are on page 39 now. And hold on to your horses, because this is a lot. So first of all, we're going to start talking about equations with two variables. And so let's imagine one is like you burn 10 calories a minute on an elliptical. I don't know if that's true, by the way. An elliptical is the machine that it's like you're running, but also floating. I used to love it back when we were allowed to go to the gym. Burn 10 calories per minute on an elliptical. So we want to write an equation for the number of calories burned in m minutes. Okay, so in this case, we have two variables. We have the total number of calories and we have the number of minutes. So for every minute I'm on the elliptical, if I am burning 10 calories each minute, I do minutes times 10, and that will give me the total number of calories for C. So this is my minutes is M, and my number of calories is C. Now, someone can give me a value to plug in there. So they might say, okay, now find out how long you were on the elliptical if you burned 100 calories. So I can say, it would probably say something like evaluate when C equals 10. This language should sound a little bit familiar to you because you've heard this before. Just we're doing less complicated things. So now I'm going to take C and when C equals 100, my bad. I'm going to take C and plug in 100. So now instead of M times 10 equals C, I'm going to do N times 10 equals 100. Now I go back to my training about what I do. I know what to do with this, right? This is multiplication. I do the inverse operation. So I divide both sides by 10, and I get that M equals 10. So I was on the elliptical for 10 minutes. Okay? There's the first piece of this. The other thing to know is two variable equations always have a variable that can be manipulated and a variable that can't, that just it is what it comes out to be. So these are the independent variable and the dependent variable. Okay, the independent variable is, in this case, the number of minutes that I can be on the elliptical. That is what I can control, or what any person could control, that they could say, I'm going to get on for 5 minutes, I'm going to get on for 30 minutes, I'm going to get on for 3,000 minutes. So that's what is controlled or manipulated. It doesn't rely on anything else. The dependent variable, let me catch up. The dependent variable is the thing that's just along for the ride. So the number of calories you end up burning after however many minutes is totally depending on how many minutes you're on the treadmill or on the elliptical. So in this case, this would be the number of total calories. It always depends on, that's why it's called dependent, depends on the other variable. So in this case, the number of calories burned depends on how many minutes we're on the elliptical. Okay, let me give you another equation or another scenario. So this equation is for the amount of milk left in the gallon sized container. I should have said jug, that'd be shorter. After you pour X cups. Okay, so this is the equation they would give you. M, which is for the amount of milk. I should have said ounces. Ounces of milk left in the gallon-sized container after you pour X cups would be M equals 128 ounces minus 8 ounces in every cup. Okay, so first of all, let's identify the two variables. One of the variables is the milk in the jug, and one of the variables is the number of cups I pour. Which one of those do I control? Which one is the independent variable? The number of cups. So X is the independent variable because I control it, which means M is the dependent variable because it totally depends on the number of cups I pour. All right, now let's imagine that we are given something and they say there are 64 ounces of milk in the container right now. How many glasses of milk have been poured? So they would say evaluate, I'm almost out of room, so I'm being stingy with what I write. Evaluate when M equals 64, there's 64 ounces left. I would do 64 equals 128 minus 8 times X. And this gets us into a whole other can of worms that I did not think about getting into. So we are going to stop there.